What's up, guys? We're going to be doing our first lesson for Chapter 3 here, which is dealing mostly with inequalities. These first few sections are going to be very review for you. They're going to be pretty quick and pretty easy, but I still need to go over a few things with you, so make sure that you're paying attention. Go ahead and pause and copy all of this down just because it helps you remember some things. First thing I want to point out is when we have, it says x is less than 3, or x is less than or equal to 3. There's a little trick here that I use to help me remember which sign is the less than or the less than or equal to. This one specifically is less than. This one is specifically less than or equal to. And this is greater than and greater than or equal to. Those words are not interchangeable. All right, so this one is the less than sign. This one is the greater than sign, even though we could read this down here as -2 is less than x. That's what that means here. All right, but x is greater than -2 is how you read it if you're reading this symbol correctly. The way that I remember that is if I'm thinking of the word less, it is spelled with an L. And so if I take this L and I just kind of rotate it down a little bit, it looks something like this. So that's how I've always remembered, is that it kind of looks like an L that's laying down is the less than or the less than or equal to. Remember, if it has a line underneath it, it means it's equal to. Now, the way these graph are like this. If it's less than or greater than, it is an open circle. Now, if you think about that, that makes sense. The reason it is an open circle is because it does not include that specific value. So x is greater than -2. -2 is not included in that, but it's any number that's going to be larger than that, going to the right on the number line indefinitely. Same thing with this less than, right? It does not include the 3. You come down here, and if it's less than or equal to, then it means it does include that value. So right here, the 0 is a filled-in circle. It's kind of hard to see there on your, at least for me, it's not super clear that it's filled in, so I'll go ahead and fill it in a little bit more. So here, this means 0 and all the numbers that are less than that. And, you know, sometimes I get students who are like, why are there two different things? You know, if x is less than 3, why not just make it one sign, you know, so that we could say, well, x is less than or equal to 2. Well, these two things do not mean the same thing, because here's why. Think, is there a number that is between 2 and 3? Yeah, there's an infinite amount of numbers between 2 and 3. If I were trying to say all the numbers that are less than 3, then I could say 2.5, I could say 2 3/4, I could say 2 9/10. I mean, there's all types of different numbers that are in between there. So there's different situations when using an or equal to makes sense, and then there's other situations where you don't want the or equal to. So we have all of those available for our use. Another couple quick tricks in terms of graphing. The arrow, as long as the variable's on the left, the arrow always points in the direction that's graphed. Okay, so the variable's on the left, it points to the left, I graph on the left of the number line. Points to the right, graph on the right of the number line. And you probably remember when you were a little kid that you learned that these signs are like alligators. That's how I learned it, at least. They're alligators, and they always eat the larger value. Yum, 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 yum. One other thing that I do want to point out that I am a stickler for is, for some reason, I always get these students that they make their number lines, and, you know, let's say I was going to graph this first one, this x is less than 3. And I start with the 3 in the middle, and then I have 4 and 5. Usually my kind of rule of thumb for you guys is I want at least 5 numbers on your number line. So 2 and then 1. If I were graphing this, I'd start with an open circle. For some reason, I always get kids that want to put the circle and the arrows above the number line, and they do this. And I don't understand where that came from. I don't want you doing that. Other teachers might have been okay with that in the past. I'm not okay with that. This goes on the line. All right, so do not do that. Just to reiterate me not wanting you to do that, I'm going to put a red circle over it because that's how intense I am about it. Red circle with a slash and more slashes. Don't do that. Write it like this. Put the line on top of the number line. That's very, very important to me. I want you doing this correctly. All right, so we have some funnies. So, dude, remember that time we did that really crazy thing, and you were like, bam, and I was totally like, whoa, and then it was all like, whoosh, and man, that was fun. You guys all have friends that talk like that, except does it end like that? Kindness. 3.2, we're going on to the next section, adding and subtracting inequalities. When adding and subtracting with inequalities, you treat them just like you would an equation and the properties of equality. In other words, whatever you do on one side, you do on the other. This is called the properties of inequality. All right, so when we're doing an equation, you'd say the addition property of equality. Well, there's an addition property of inequality that works exactly the same way. All right, so let's take a look at how this plays out. So let's find the solutions, then graph the solutions. Well, here it has x minus 15. I want to isolate the variable. So in order to undo that, I'm going to add 15. That leaves me with x. And then this sign just comes down. When it's addition and subtraction, the sign comes down. X is greater than 3. And then it says to graph my solution. So I start with a 3 in the middle. I always put whatever number I'm graphing in the middle and then fill in on the other sides. I get students that oftentimes think that 0 always must be in the middle of a number line. That's not true, and that would stink if you're using numbers up in the thousands or negative 10,000s or all types of different numbers. So here, open circle, make it very clear for me that it is open. You could be kind of ridiculous on that. I mean, I don't need a circle the size of the planet, but you get the idea. And then make it very clear which side is being shaded in. Okay, so this one, arrow points to the left. I'm going to shade in the left as long as the variable's on the left side of the inequality. That works. Let's come over and look at this one. I'm going to subtract 6 from both sides. So that leaves me with t is bring down your inequality greater than or equal to negative 10. So I need to graph the solution. So I start with negative 10 in the middle. Be careful. This is a very, very easy mistake to make. As I'm starting at negative 10 and I'm going to the right, I'm counting up. When you count up in the negatives, remember you're doing that. Intuitively, we want to go 11, 12, and that on that side. Well, when you're in the negative land, remember everything's the opposite there, so you got to be very careful with that. It's underlined, so I fill it in, and it's all the numbers that are greater than that, so I fill in this side of my number line. And this is a pretty straightforward section. I don't think you guys are going to have any problems with that. I believe that's it. I'll see you in class. Have a good evening.